We're going to continue factoring today. This time we're going to factor ax squared plus bx plus c. We're going to find out what do we do if we have a leading coefficient that isn't 1. We'll find out different ways to do that, and you'll apply that and do some work and practice with that, and you'll find out it's not so difficult when we have a value of a. So, first question, what happens if our polynomial starts to negative? We were working with problems the other day that said x squared plus bx plus c. Well, what if it's negative x squared plus bx plus c? How does that throw things off? Well, the only solution I see is let's get rid of the negative. So let's divide everything by a negative. Let's factor out a negative. So if we factor out a negative, we'll have negative 1 times x squared minus bx minus c. And then it's easier to work with, because now I know how do I get x squared? It's going to be x times x. I don't have to worry about is it x times negative x. So let's do that here. Got a negative leading coefficient. Let's divide by a negative 1, leaving me with x squared minus 2x minus 8. And then we go to our diamond. I've got to get a product of negative 8 and a sum of negative 2. How do I do that? Well, think of my factors. 4 and 2, or 1 and 8. Well, the 1 has to be negative, negative 4 and 2. So I got negative 1 out here, and x minus 4, and x plus 2. Problem solved. Who cares about those negatives? Moving along, what happens now if we have a value for a here, like a 3? Well, a couple ways we can think of this. One way, I'll show you the AC method in a moment. Don't let me forget about that. But right now I'm just going to factor it, just thinking how it works. Think of the product. So 3x squared plus 14x minus 5. So thinking about it, think I have to multiply to get these, multiply to get the last term, then this is the sum term. So think, what are the only ways to get 3x squared? Well, x times 3x. And think of my products of negative 5. Well, it could be negative 5 and positive 1. Or it could be positive 1 and negative 5. Well, I've got to get a sum of 14. Well, I can't figure out my sum. So let's check how we get that sum of 14x. So let's multiply it out. So here we have to do a little bit of guess and check. X times 3x is 3x squared. X times 1 is plus 1x. Negative 5 times 3x is negative 15x. And negative 5 times 1 is negative 5. So that gives me 3x squared minus 14x minus 5. So we almost have it right, just the sign is wrong. So let's flip these around. Let's say instead of x minus 5, let's do x plus 5. And instead of 3x plus 1, let's do 3x minus 1, because that'll still give us a product of negative 5. Multiply that one out, I get 3x squared minus 1x plus 15x and minus 5. Combine all my like terms, I get 3x squared plus 14x minus 5. So I get the final solution of what the product should be. It should be x plus 5 times 3x minus 1. So it took me 2 tries, but I got it. And this one is a little bit simpler. If I were to try that with, let's just take a look at like 10x squared and 6. We've got more choices, because the ways to get 10 could be 1 and 10, 2 and 5. 6 is 1 and 6, or 2 and 3. I've got to try all those combinations, and that's going to take a lot of time, and you don't have a lot of time, and you don't want to waste a lot of time. Sometimes you can think of those and come up with what they are just by testing the different combinations in your head. But there's a quicker and simpler way. Let me teach you the AC method. Not air conditioning, but AC, because it deals with the A and the C of our quadratic equation. So AC, we're going to combine those. I'm going to multiply the A times the C. So I'm going to take my A and multiply it by my C. And that's going to give me x squared plus 14x minus 15. Because 3 times negative 5 is negative 15. Now this looks manageable because it looks like something I've done already. So I need to get a sum of negative, or product of negative 15 and a sum of 14. So think of what I need to do. One's positive, one's negative. So 15 and 1. So I say x plus 15. Actually, one of those needs to be negative, right? So minus 1. Times x minus 1. Now, since I took that 3 and moved it over here, I need to put that 3 back in. So I'm going to put it back in both of these. Okay? So I just multiplied it over, but now I need to put it back in because I need to divide it out. Because I borrowed the 3, now I need to take it back. So look at one of these. Can I factor the 3 back out? This one I can, right? So if I factor out the 3, divide 3 out, I have x plus 5 times 3x minus 1. And that looks just like what I had done before by trial and error. So the key here for the AC method, I've got to multiply the A times the C, and then I don't know which one I need to divide it out, so I put it back in both factors, and then I need to divide that 3 out. Since I multiplied it before, I need to divide it back out. Okay, so let's try another one. 3x squared minus 19x plus 30. So I've got an A value here, I'm going to multiply it. So I have x squared minus 19x plus 90. Getting bigger numbers, so bigger products. Is that right? So I need a product of 90 and a sum of negative 19. Sum is negative, means both my terms are going to be negative. So negative 10 times negative 9 is positive 90, and it adds up to negative 19. So I'm going to say x minus 10 and times x minus 9. But since I multiplied by 3, remember I need to put that 3 back in so I know which one to divide it from. I can't divide from this one, but this one has common. So I'll divide that out and I'll be left with 3x minus 10 times x minus 3. So just keep in mind, if you borrow that A, I need to divide it back out again. So here I got a value for A, it's 6. I'm going to multiply that by my C value. Leaving me with x squared minus 5x minus 24. Set up the diamond. Product of negative 24 and sum of negative 5. So the product's negative, so I have one positive, one negative. Think of my factors: 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now one of those is negative, so I'm looking for the difference, a difference of 5. This isn't going to work. This is 10, this is 5 apart. It's only 2, so 3 and 8 are my two numbers. I have to have a sum of negative 5, so 8 needs to be the negative. So x plus 3 and x minus 8. Remember, since I multiplied my A value over, I need to put it back in because I need to divide it out somewhere. So now I need to divide 6 out of these. This one, they're only divisible by 3. And this one is divisible by 2. So here's where I get my 6 out of there. 3 times 2 is 6. So I just need to get a combination of whatever that A value is. Here it worked out because I multiplied by 3. I can divide 3 evenly out of this one. I can't divide 6 evenly, so I need to divide it out of both of these. So I get 2x plus 1 times 3x minus 4. So you'll find that this method works a lot more efficiently than just trial and error. And I think you're going to want to try this method out because it'll save you a little bit of time. So why don't you try the next two examples on your own, see if you can get those, pause the video, start it when you want to see my work for it. So first one, I multiplied the a by the c. 8 times 9 is 72. So I had to get a product of 72, sum of 18, so I used 12 and 6. So I had x plus 12, x plus 6. I had to put that 8 back in so that I could divide it out. Divide 4 from the first term, 2 from the second term. Now left me with 2x plus 3 times 4x plus 3. Next example, I multiplied the 10 by the 6 to get 60. So I set up my diamond. So 60 as the product, negative 19 as my sum, negative 4 and negative 15. Fit both instances, so x minus 15 and x minus 4. Put my 10 back in so that I could divide it out. Divide this one by 5 and this one by 2. Leaving me with 2x minus 3 and 5x minus 2. So that is the AC method. I like that method. I prefer it over the guess and check method. If you're interested in another method, there's one known as the British method that Mr. Huebner is a fan of. So if you are British, or if you just like the British method or anything British, maybe you want to try this one out. I'll show you how this one works. Kind of similar to the AC method. So we multiply the A term times the C term. So we get 24x squared. And then we have to figure out how to split that up into two terms that add up to 11x. So it's kind of like the diamond in that we're looking at, we multiply the A and the C together, and we still need to get that sum of 11. So we know that that has to be 8 and 3. So that one gets broken into 8x plus 3x, and then we have 4 terms. We keep them all together in this method. So then we take a look at each group, and we look to find a GCF out of each one, and we keep those in here. So here I pull out a 2x, because I can divide 2x from both of these terms. 2x squared divided by 2x is x. 8x divided by 2x is 4. Here I have 3x and 12. I can divide those both by 3, so I pull out a 3, leaving me with x plus 4. So with these terms, now they both have x plus 4 as a common factor. So I can factor that part out. And I'm left with, when I divide that out, I'm left with 2x and 3. So that's where the 2x plus 3 comes in. So maybe you like that method better. So choose whatever method you like. Hopefully I didn't confuse you showing you both methods. But just choose a method to help you factor these polynomials when they have a leading coefficient. So I've shown you extensively the AC method. If you'd like to know more about that British method, I can show you some more in class. Or talk to Mr. Huebner about that.